Hi everyone. In this video I'm going to be talking about long division and specifically how it's applied to polynomials, how we use it with polynomials. And it's absolutely possible to divide polynomials using the traditional division, long division. And I'll show you how. What's a polynomial? I'll give you an example of a polynomial. X squared minus 3x minus 10, right? This is a normal polynomial. And sometimes these polynomials get divided into something. Say x plus 2. Okay, you might think, well, yeah, there's one thing you can factor this, but how would you, actually divide it? If you would need to use long division, how would you set this up? Okay, well, let me ask you another question. How would you do this? By 9. How would you do that? Well, you could use your calculator, but, if you would want to set it up using long division, well, you would just put the divisor here and 765 here, and you would slowly unfold the answer. So obviously 9 doesn't go into 7, it's too big. 9, what about 76? Well, 9 times 8 is 72. 9 times 9 is 81. That means 9 can't be the answer, can't be the number, it's too big. So 8 is our closest. Then we would multiply this by the divisor. 8 times 9 is 72. And we would subtract. 7 minus 7 is 0. 6 minus 2 is 4. We would bring down the 5, right? I hope you know this. And we would do the step all over again. We would say, how much times does 9 go into 45? Well, luckily for us, 9 goes evenly into 45 5 times. 9 times 5 is 45. So, and we would multiply. 9 times 5 is 45. We would subtract. 45 minus 45 is obviously 0. That means we have 0 remainders. 0 as the remainder, which means no remainders, and 85 is our answer. So we can do this exact same thing to polynomials such as this. Okay? So I'm gonna simplify this or solve this using long division. But before I do that, you might be thinking, hold on, I can factor this. This is easily factorable. But there are problems in polynomials that we're going to encounter that are not that easy to just, factor. But if you would factor this, you would simply get, well, x minus 5 and x plus 2, right? That makes x squared minus 3x plus 10, minus 10. And in our denominator, we have x plus 2. Same terms, same x plus 2, they cancel, and you're left with an x minus 5. Now, I'm going to use long division to do this problem, and we'll see if we can get this answer. Okay? So let's set it up. Same way, when we put the 9 in this position right here, we put the x plus 2 in this position. And this whole thing goes in here, inside the dividing thing, brackets. X squared minus 3x minus 10. Great. Okay. So we solve this problem the same way we did this one. We ask, how much times does x go into x squared? In other words, what do I have to multiply x by times what? That will give me x squared. Well, that's pretty easy. X times x is x squared, right? That's really what you are doing. So x goes x times into x squared. Oh, I forgot to say something. If your answer, let's say, is x, you would align it. This is I don't know if everybody does it this way, but I like to be very organized with my answers, so I would, since it's an x, I would put it under the x column, 3x, So my answer wouldn't go here because this is the x squared column. x. So it will be helpful when you're dealing with very hairy problems, okay? Okay, and since you got that answer, now you would multiply this, not just to the x, but to the 2, because this is one term, okay? So x times x is x squared. You would put it under the x squared. X times 2 is 2x plus 2x, right? And now you would actually subtract this whole term from this, x squared minus 3x. Remember to always put this minus sign because you're really distributing this minus sign inside the bracket. So x squared minus x squared cancels, which is a 0. Minus 3x minus 2 is minus 5x, right? And like we brought the 5 down here, we would bring the negative 10 down here. It's like another round, second round, and we do this problem again, like we did again with the 45. So x times what equals negative 5x? Well, negative 5, right? Negative 5 is a constant. We put it under the constant column. And you would multiply this negative 5 times this term. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. Remember to always put the minus sign. You are subtracting. Negative 5, negative times negative is a positive, so negative 5 plus 5x. It cancels, you get a 0. I don't know how to write it. Negative 10 plus 10, that's a 0. So you're left with 2 zeros, or okay, just a 0. And your answer is a clean x minus 5, okay? So, and is that our, yes, it is our answer. That's what we got in our first, when we factored it, we got the same answer. That means everything is correct. Oops. And you might be thinking, well, this is much longer, you know, this is so much easier. But like I said, not all problems are factorable. And we're going to do one right now, actually, that is not factorable. In other words, you're going to have a remainder. Okay, so this was no remainders, right? We got 0. Because I'm dividing this video into 3 parts. So this is the no remainders. 0, 0, well, this is numbers, but 0 is your remainder here. What about remainders? Bad writing. Okay. What if I give you something like this? 2x squared minus 5x minus 1 divided by x minus 3. And you know, you might think this problem, it's not that hard, but try to factor it. You will not be able to get a clean factors, just like we did here. Okay? And the answer is going to be a little bit different. Maybe a little bit messier, but no, but it's fairly a short answer, so it's okay. Okay, let's start. Let's use long division. So we're at x minus 3, the divisor goes here. We're dividing it by 2x squared minus 5x minus 1. Keep in mind, just keep this in mind because we're going to encounter something in our next part after we do the remainders, that each term here, the exponent of the variable x descends by 1. So first it's an x squared, then it's just x to really the first power, right? And then you have no x, that means to the 0th power, so nothing is here. I mean, you know, you have no x, no variable. So everything goes down by 1, okay? Just keep that in mind. I'm not trying to scare you or anything, because in the next problem we're going to be talking about that. Okay, enough talking, let's see. So, let's ask the same question. how much times does x go into 2x squared? Well, x times what equals 2x squared? Well, 2x, correct? Okay, so 2, oh, right, you see, I even mixed it up. 2x is not, it goes in this column, right? It's 1x. Yeah, and now we would multiply this by this thing. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Right? Remember, you are subtracting this. 2x squared minus 2x squared is 0, right? Negative 5 plus, remember, plus 6x, it was just an x, right? 1x. Now you would bring this negative 1 down, and you would do the same thing again. X times what equals x? Well, x times 1 equals x, right? So x goes into x 1 time, plus 1. 1 is a constant under the constant terms. Multiply 1 times x is x. 1 times negative 3 is negative 3. You're subtracting. X minus x cancels. Negative 1 plus 3 is positive 2, right? And we can't do this any further, right? Because you don't even have an x term here. So this is something called a remainder. Remainder. Okay? Now you might be thinking, well, what do I do with this remainder? Do I just attach it here? No, you don't attach it. You have to perform something. So what I'm going to do is copy this answer that we got, our partial answer, 2x plus 1. What you would do now is take your remainder, since it's a positive, it's not a negative, you would add, it's a positive, to the remainder over the divisor. The remainder, which is a 2, over the divisor, x minus 3. Okay, that's how it works. Because let me ask you something. What if I give you an easy problem? What about 5 divided by 4? Right, if we would actually do this, 4 goes how much times into 5? Well, 4 times 1 is 4, 4 times 2 is 8, so, 4 goes once into 4. 4 times 1 is 4, you would subtract 5 minus 4 is 1, correct? Now, if you check your calculator, or really think about it, well, on your calculator, the answer will be 1.25. But how do you think you get this 0.25? We have the 1, but where does the 2.5 come from? See, what happens is, you have your 1. If we do that thing that I was talking about, taking the remainder, because 1 is the remainder here, right? 1 over the divisor, you get 1/4. And if you change this to a decimal form, 1/4 is 0.25. And that's how you get your answers. Okay? That's why your calculator shows 1.25. Just a little nose. I just want you to understand what I mean by that with numbers. So that's your answer. You would take your remainder, just keep that in mind, and put it over the x minus 3, your divisor. And that would be your, this is really the simplest form you want it to be in. Okay, so great, we took care of the remainder part. And now the last part is a little more, okay, you'll see. This section is called the missing terms. Okay? This is what we're going to be talking about, because these problems come up a lot in tests, exams. These, they test you on these ones, because these are a little bit, you have to think a little more. Okay, what if I gave you a problem like this? X, I'm gonna put it in, okay, x to the 4th minus 81 divided by x minus 3. Okay, let's use long division to solve this. And if we would, we'll get, well, this is a divisor, so you get x minus 3 divided by x to the 4th minus 81. Okay, see, we have a problem. And you may not notice it because, well, this looks easy, let's just go on. But remember how I said in our previous problem that the exponent of the variable descends by 1? So everything goes down by 1. And we need that in order to do long division. Okay, we need everything to go down by 1. But this is x to the 4th. And all of a sudden, x to the 4th goes down to a constant, meaning no variable, no x to something. We can't have that. So the rule is, when you have something like this, when you don't have this pattern going on, plus constant, so something here, coefficients here. But when you don't have this 4, 3, 2, 1, you need to fill that in by writing 0x to that power for any missing terms, basically. I'll explain this with the example, don't worry. For missing terms. It's the first time, I know, but it'll make sense as you go on with practice. Okay, so let me rewrite this problem with what I just said. Okay, so we're gonna have, well, we have an x to the 4th. That's our beginning, the highest power, the 4. What comes? We're descending by 1. We're going down by 1. That's how it works. It has to go down by 1. We can't jump from a 4th to a constant. That doesn't work. So we can't have an exponent jump. So then we would add, since we don't have an x to the 3rd power, our coefficient is going to be 0, and the exponent power is going to be 3. Okay, since we don't have an x to the 3, we have to fill it in. What comes after, before 3? 2, correct? We don't have an x squared term here in our problem, so we have to fill it in by adding 0x squared. Now x to the 1st power, we also don't have that one, so this is a very, we need to fill in a lot of things here. So we would add in a 0x to the 1st, so we just leave it like that. And after that comes the constant, right? Comes the constant. And we do have a constant. We have a negative 81. That's our last. So they give us a beginning, the highest, and the last. We need to fill in everything inside. Sometimes you will be encountering problems like this. And you always need to pay attention, pay a close eye on those exponents, on how the problem really looks and what you're working with. Okay, let's do the same, and now we just follow the same pattern, the same steps, and you will see there's no change that I added the 0. This won't, give us any problems. This is gonna make a lot of sense now, actually. If we wouldn't have this, we would, it would be messy, we wouldn't get anywhere, really. Okay, so let's see. X times, how much times does x go into x to the 4th? Well, x to the 3rd times, right? I'm just gonna do that. Notice x to the 3rd times x is x to the 4th, correct? So that's how much times x goes into x to the 4th, x to the 3rd times. Okay, and look at this, I lined it with the x to the, the 3 exponents. Always try to do that. So now let's multiply. X to the 3rd times x is x to the 4th. X to the 3rd times negative 3 is negative 3x to the 3rd. negative 3x to the third, correct? And we are subtracting this. So our first round, x to the fourth minus x to the fourth, that cancels. 0 plus 0x to the third plus 3x to the third, right? Minus plus is 3x to the third. Okay? And we just bring this down. Pretend it's part of our problem. And it really is. Well, it's not, but we are supposing it is. So everything will make sense and everything will go smoothly. We bring that down and we get plus 0x squared. And again, x times what is 3x squared? Well, 3x cubed. That is 3x squared. 3x squared times x is 3x cubed. Okay? So let's multiply this by this. 3x squared times x is 3x cubed. 3x squared times negative 3 is negative 9x squared. Okay? We're subtracting this. This cancels. 0 plus 9 is 9x squared. And let's bring down the 0. Again, we are almost done. No power. It's really to the first power. We don't need to write it. Okay. 9. How much times does x go into 9x squared? Well, 9x times, right? Plus 9x. 9x times x is 9x squared. 9x times negative 3 is negative 27x. We're subtracting. This cancels. 0 plus 27. Oof, okay. 0 plus 27 is 27x. And our very last round is this negative 81. We bring it down. And we say, how much times does x go into 27x? Well, x times 27 is 27x. So, plus 27. 27 times x is 27x. And 27 times negative 3 is negative 81. We're subtracting. 27 minus 27 cancels. Negative 81 plus 81 cancels. So you get a 0 as the remainder. Whew, okay, this was a long problem, but this is a great practice if you are having, a test anytime soon, or exams, SATs, whatever. You will definitely encounter problems like these. And this is our answer. X cubed plus 3x squared plus 9x plus 27. A fairly clean answer. Okay? Thank you for watching. I apologize if I confused you with this last problem. I know it's just, the only thing it's a little bit longer. That's it. Just remember the missing terms rule, which is this. 0x to the whatever for missing terms. That's so terrible. And remember the remainder, what to do with the remainder. Take the remainder and put it over the divisor. And that's it. Just use the rules that you really know. You know them. It's just different notation, a different fashion. And practice really makes perfect. Practice as much as you can, as much as you want, and you will ace it. This will seem like a piece of cake to you. Thank you for watching, and I'll see you next time.